Today we'll discuss radians and its application trig functions. To start off, what are radians? Radians is like degrees, where it's a value to measure the angle within a circle. So in degree mode, this would be 0 and 360. This would be 270, 180, 90, 45, 270, 215, or 225, 315. And these are the main angles, and these values represent, obviously, the angle. Now, radian mode would be the same circle, but the values are different. In degree mode, a full rotation is equal to 360 degrees. In radian mode, it's equal to 2 pi, which means the values in between would be pi over 2, pi, 3 pi over 2, and others such as pi over 4. Now, we get to see radians and trig functions. To figure this out, we're giving loads of information, like Cooper was riding a bike, the circumference of the wheel, which will become very helpful, the period, which would be 5 seconds, the maximum and the minimum, which is 27.1 and 24.9 respectively, and Cooper was smart enough to determine the phase shift of the cosine function, which would be 3 pi over 5. Now to start, we want to find the value of our a, or our amplitude. To find amplitude, if we look at our parent function, amplitude would be our distance between the max and the min from the midline, or the middle. And so to find that, we do our max minus our min, divided by 2. And our max in this situation would be 27.1. Our min would be 24.9. If we subtract those and divide by 2, we get a value of 1.1, which is the number that goes into A. Now for our B, we were generously given the period of 5 seconds, so we can actually rearrange it so that B is equal to 2 pi over 5, because we'd rearrange the original equation, which would be period equals 2 pi over the C. And that is the number that is going into the B value. Now, D is also very simple. Like amplitude, we take our max and we take our min. Unlike amplitude, we actually add it. So it'd be max plus min divided by 2, and that equals 26. And that's the value that goes into our D. Now for C, C is equal to phase shift, which was given to us by Cooper. And he told us the phase shift is equal to 3 pi over 5. Now, if we put that all together, the function should look something like this, where it's distance equals 1.1 cos 2 pi over 5 time plus our C value, which was given by Cooper as 3 pi over 5, and our D value, which again is our vertical shift. Now, this is where it gets a little confusing. We found the equation using the information given to us. Now we have to use the equation to determine the time it took for the nail to cross the elevation of 26 meters. So we start by putting in 26 as D. So it would be 26 equals this equation. Now we see there's a 26 on both sides. We can remove that by subtracting 26 and 1.1 with the same concept. So 0 would just be equal to cos 2 pi over 5 time the desired time plus 3 pi over 5. And the way we further get rid of this is we have to isolate this part and get rid of cos. And the way we do that is we do inverse of cos 0 equal to this. And inverse cos of 0 would be pi over 2 plus n pi. Now, what does the n pi represent? Well, cos inverse 0 could be pi over 2, 3 pi over 2, and 5 pi over 2. And if you look closely, you see the difference between each of these numbers is pi. And to get from here to, let's say, here, you'd have to go 2 pi or 2 of these. That is exactly what the n represents. The n represents the 2 in this scenario, where it would be the time the nail reached the elevation. So pi over 2 equals n pi, or plus n pi, would just be 2 pi 5 time plus 3 pi 5. And from here, we can actually rearrange the equation pretty simply to equal time plus 3 pi over 5 equals 5 over 4 plus 5n over 2. And again, rearrange it by subtracting 3 pi over 5 on each side. We have successfully isolated time to equal 5 over 4 plus 5n over 2 minus 3 pi over 5. Now we need to find what n is equal to. And that's very simple. If we look at our graph, or something like that, obviously it's a little different, but it gives you a realization. The parts where a nail crosses 26 would be these 3 points. And n would be equal here to 0, here would be equal to 1, and here 2. And the first time hit the nail, the second time hit the nail, and the third time. So we need to find for this one, where n is equal to 2. So that's exactly what we're going to do here. We're going to take our n, and we're going to put it in here. So then time is equal to 5 over 4 plus 5 times 2 over 2 minus 3 pi over 5. Now, you can just cancel those out. So our time is just equal to 5 over 4 plus 5 minus 3 pi over 5. If you plug that into the calculator, very simply, make sure it's in radian mode when you do that, you get 4.37 seconds. And that would be our answer to the question.